In this video, we're going to be going over the properties of compounds, and the two compounds that we're going to look at are ionic compounds and molecular compounds. So we're going to look at the properties of both of these two compounds in this video. And this is part 9 video inside of chemistry, chapter 2. So let's get started with this video. So the first thing that we're going to talk about is the physical state of substances. So all substances can be categorized in these 4 different states. So for the first one, we have solid, and the abbreviation is just S. The second one, we have liquid, and the abbreviation is just L. For the third one, we have a gas, which the abbreviation is G. And for the last one, we have aqueous, and the abbreviation is AQ. And some examples of each of them. So for solid, we have just iron, which is Fe. And for another example, we have sodium chloride, which is salt, NaCl. For liquids, a common example, and the one that we use every single day, which is water. For gas, we have helium gas, nitrogen gas, hydrogen, oxygen, all of those are gases. And finally, for aqueous, which means that it can be dissolved in water or not. And for the example we're using is sodium chloride solution, so which is NaCl. So NaCl can also be dissolved inside of water, so we can also write AQ at the end for abbreviation. So this table in summary shows different physical states of substances with examples of each. And now we're going to talk about bonding in substances and their properties. So chemists can deduce a lot about structure and bonding within a substance by examining its physical and chemical properties. So such properties include the structure of the substance, as well as its melting and boiling points, and additionally, the ability of a substance to conduct electricity can offer insights to the type of bonding it possesses. So what chemists do is with these different types of things such as conducting electricity, melting and boiling points, they can tell whether a structure has a strong bond or if it has a weak bond. And we're going to look at in the further slides if the ionic compound or the molecular compound has a stronger bond. So now, since we know that chemists can deduce a lot through these different types of experiments, let's see how we can use that information in order to learn more about ionic compounds and molecular compounds and their properties. So properties of ionic compounds. So we're going to talk about ionic compounds first. So first we're going to discuss the properties of ionic compounds, and we're going to focus on the example of sodium chloride, which is salt, and here is a brief summary. So here we have 3 different pictures, and we're going to go one by one throughout each picture and see what it explains. So for picture A, we are displaying sodium chloride in its solid form and highlighting its crystalline structure. And the caption of the picture notes that NaCl has a relatively high melting point of 801 degrees Celsius. So first of all, we know that from our previous videos, all ionic compounds have strong bonds because of their crystal lattice structure. So in the first picture, we can see that it's in solid form. It has a crystalline structure because it's all together properly. So we know that ionic compounds have a crystalline crystal lattice structure. And then another thing that we know is the melting point. So the melting point is at 801 degrees Celsius, which is really high. So since it's really high, all ionic compounds usually have high melting points. So that's what we're trying to get out from our first picture here, which is letter A. So moving on to our second picture, B shows sodium chloride dissolved in water, and it forms an electrolyte solution. And this demonstrates that when NaCl is dissolved, it dissociates into constitutional ions, which means Na plus and NaCl minus, which can move freely in solution and conduct electricity. So another property of ionic compounds is to conduct electricity. And for the letter C, it depicts an attempt to measure electrical conductivity in solid sodium chloride. And since the ions in solid NaCl are locked up in place within the crystal lattice and cannot move freely, solid NaCl does not conduct electricity. And this is indicated by the lack of response by the conductivity meter. So this is another property that we found. So in its solid form, ionic compounds do not conduct electricity, but when they're dissolved inside of water, they do. So for a brief summary of the ionic compound, they all have crystalline structures, they all have high melting points, and they all also conduct electricity. So that summarizes everything for ionic compounds. And now let's move on to molecular compounds. And the example that we're going to use is glucose. So glucose in its solid form is an aqueous solution. So as we can see in the first picture, that is glucose and it's in its solid form. And on the right, we have glucose in its aqueous solution. So in the first image, a conductivity meter is inserted into the solid glucose, and presumably the meter does not show any conductivity. And then the image states that glucose also does not conduct electricity in either solid or also an aqueous solution, reinforcing that it is a molecular compound. So in this case, in the solid form it does not conduct electricity, and also when it's mixed inside of water, it still doesn't conduct electricity. So one property of molecular compounds is that they do not conduct electricity. And furthermore, stable when heated. So when molecular compounds are heated, they do not readily break down into other compounds or elements, such as what happened with the ionic compounds. And for example, when H2O or water is heated, it only changes state. It does not change into other compounds or elements. So like when you have water and you melt it, it's a liquid, and then when you heat it up, then it's going to turn into a gas. So it's still water, it's just changing the states. And furthermore, these are non-electrolytes. So molecular compounds are usually non-electrolytes, meaning that they do not conduct electricity in any state. And this is because they do not have ions, but they consist of neutral molecules. But on the other hand, we already know that ionic compounds are electrolytes in the liquid form. And furthermore, for the low melting points, so molecular compounds generally have lower melting points compared to ionic compounds. And this indicates that in between molecules, there is relatively weak, and also it requires less energy to overcome. So when you heat water up, you only might need about 100 degrees Celsius. But for ionic substances, you need 800 plus. Sometimes you might need less, but most of the times it's really high. So this is the difference between molecular compounds and the properties of ionic compounds. So for some final words, we talked about molecular compound properties, ionic compound properties, and in our upcoming content, we're also going to talk more about ionic and molecular. So thank you so much for watching from Try to Be Useful, and we'll see you guys in our next chemistry video.